what are some properties that electromagnetic waves have? So first, all electromagnetic waves travel at the same speed, the speed of light. So whether you're talking about a radio wave or an infrared or visible or ultraviolet or X-rays or gamma rays, all of these different kinds of light travel at the same speed, the speed of light. So do not screw up on the exam when I say which is faster, an X-ray or a radio wave. Okay, so what's the correct answer? Samey same. All right, so that they are the same. An X-ray is going to travel at the same speed as a radio wave, the speed of light. And how fast is the speed of light? It's going to be 3 times 10 to the 8th meters per second. So that means that if you want to go from Earth to the moon going at the speed of light, which is full impulse power, or warp 1 if you're a Star Trek fan. So if you wanted to get to the moon, you could do it in the blink of an eye. So roughly like 1/2 of a second is how long it would take you to get from the moon to Earth going at the speed of light. If you wanted to go to the sun, that's going to take you like 8 minutes going at the speed of light. All right, the second thing I wanted to mention is that the speed of any wave is given by the letter V. So V stands for speed. Not to be confused with that one. Okay, so that one stands for frequency. So the speed of any wave is going to be equal to its wavelength times its frequency. Okay, but how fast does light travel? It travels at the speed of light. So instead of the letter V, we can put in the letter C. So the speed of light is equal to the wavelength times the frequency. Okay, now notice that for radio waves have a very large wavelength. So what does the frequency have to do in order to compensate? Remember, 4 is equal to 1 times 4, but it's also equal to 4 times 1. So that means that if this letter gets bigger, then this letter has to get smaller in order to compensate. So whatever this frequency is in hertz, when you multiply it by this wavelength in meters, you end up with 3 times 10 to the 8th for a radio wave. But if you go over here to the gammas were the ones that had the large frequencies. So what does that tell you about their wavelengths? Well, in order to compensate, this would have to get smaller. So that whatever the wavelength for a particular kind of light is, if you multiply it by its frequency, you'll always end up with 3 times 10 to the 8th. So that's the reason why you have this thing right here. Okay, another interesting thing that comes out of quantum mechanics is what is the energy of a single photon of light? So light comes in these teeny tiny particles, which we call photons. So what would be the energy of one photon? And it turns out that energy, so E for energy of a single photon, is going to depend on its frequency. And then a fundamental constant of the universe called Planck's constant, which is not that important to us. But this H thing is a fundamental constant of nature, and I went ahead and gave it to you if you're interested, but you're not going to be using it on the exam. What you are going to be needing to know is if the frequency gets bigger, what has to happen to the energy over here? So let's say, for example, that we double the frequency. If you double the frequency, whatever you do to one side of an equation, you got to do to the other side. So if it's 2 times the frequency, it's going to have 2 times the energy. So as the frequency goes up, then the energy goes up. And if we look over here, radio waves have the smallest frequency, and then the gamma rays had the largest frequency, but look at their energies. It's following the same pattern. Small frequency, small energy, large frequency, large energy. And it's all because of this thing here. So we have light wave number 1 has a certain frequency, and light wave number 2 has a smaller frequency. It has half of light wave 1's frequency. How do their energies compare? So we're going to plug in a 1/2 there, and so that's telling us that light wave number 2 is going to have half the energy of light wave number 1. All right, let's take a break. When we come back, we're going to talk about color.